right, welcome everybody to another episode of the Puget Systems podcast. I like saying that so much; it feels good. This week we're joined by our scientific computing advisor, Dr. Don Kinghorn. It's been a while, I think, since you've been on the show, huh, Don?
It has
I
been.
think so. Yeah,
It
it's
has
been a
been.
bit.
I don't remember the last one. I remember a lot of them that were really fun. I do remember that, but no, I haven't. We haven't done this for quite a time.
Yeah, I can't. Actually, yeah. Now that you mentioned, I can't recall what our last topic was, but that's okay.
I bet
You
you it's
know,
been a year.
that feels right. That feels right. Probably, actually, yeah. That's probably around the same time. Yeah.
Yeah, but, we've been doing so many other things on during this time. So,
Yeah, it's busy.
but hey,
So yeah,
I'm here.
we're, that's right. This will be cool. So today we got a few different things we're going to touch on. GTC, which
Mhm.
overlapped with GDC. And so I know like Puget didn't put out a whole lot of content around GTC, even though it is, relevant to our interests and stuff. We're going to be talking about the LTSP.
I'll explain.
Yeah, so I skimmed through that article when it first came out, and I've in preparation for this, so that'll be really interesting as well. I think that's pretty cool. You'd mentioned MicroMamba. I know that you've got an article about that, and Enroot container bundles. I know that one for sure because that's like
Yeah.
that was a fun. That's the Docker without Docker, as I recall.
Yes. Yeah. This
Yeah.
goes back to our very first stuff when you were doing streams
Oh,
as a builder.
that's right, way back. Yeah.
Yeah. Yeah.
So
Yeah.
this will be cool. I guess where would you like to start, Don?
Well, uh, I think I'll start in with GTC.
Sure, sure.
Um, I'm just all I'm doing is just kind of giving my feeling of kind
Mhm.
of you know just how it felt,
Sure.
how it felt this year, and I really wanted to mention it. I've been actually planning on doing a little blog post, but I'm not sure if I'll do it or not. But yeah, GTC, that's NVIDIA's tech conference,
Yeah.
and it's huge. You know, it's always been one of the, at least in my opinion, one of the premier meetings of the year.
Cool.
In fact,
Cool.
the two must attends for me have been GTC and supercomputing.
Yeah.
And there's a lot of crossover there because NVIDIA is just like they're it,
Oh yeah.
right?
Yeah.
Yeah, and especially for machine learning and AI, they're just killing it. They have been for years. In fact, they are largely responsible for the state of things now.
Mhm. Mhm.
You know, um, but almost entirely responsible for it. Wouldn't have
Yeah.
happened without their efforts.
Oh yeah. You've
So
mentioned before that their support, I suppose, of CUDA and making it really easy to use for the folks who are doing that sort of work. And I know we've mentioned a few times too that it seems like a lot of their consumer stuff, the gaming side of NVIDIA, is really just kind of a front for all of their machine learning and AI stuff. It seems like that's like the dog and pony show for what their serious business.
yeah, it's crazy. I mean, it didn't used to be. I think it really has kind of flipped that. You
Mm.
know,
Mhm.
these days, because man, they're doing supercomputers now, and
Yeah.
I mean,
Well, oh,
outstanding ones. I mean, they're driving
yeah,
the whole
that
thing, and
they had that
so many
cool
good people working there. It's amazing.
they had that cool DGX box
Oh
years
yeah,
ago. I think it's like a $10,000 turnkey machine learning box. You just boom, it's like ready to go. I think that was really cool.
yeah, more like 100,000,
Oh, okay. Well,
and now a couple
dropped
100,000.
dropped to zero.
Um,
I suppose.
yeah, 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 but that's okay. Really killer stuff.
Yeah.
Yeah, they've got all kinds of stuff going on. They acquired Mellanox, so now they
Oh,
basically
that sounds
own
familiar.
uh, the heavy iron high performance backbone stuff. So
Oh, yeah.
they've got they've got a lot of the pieces. They almost got ARM, which would have been really super for them, but it doesn't matter.
Yeah.
They don't need ARM. They don't need to own ARM.
Okay.
So, that was kind of cool, but it was very controversial. That kind of rubbed a lot of people the wrong way. So maybe it's best that it, kind of got shot down in the EU.
Right.
Um, but but anyway,
Yeah.
yeah.
So did you?
Yeah. Just on that thing about NVIDIA kind of driving this whole thing forward. I feel like I went to a conference, a meeting at NCSA, National Center for Supercomputing Applications in
Okay.
um, Urbana. And this was in, oh man, it was like 2007 or something. It was way back, but this was the thing that this meeting was about was basically accelerator architectures. And this was the meeting where everybody had been working on stuff for like a year or so, and
Mhm.
it's like everybody's back, and it's like, what works? How did it go? It was very interesting. It was great. There was,
Cool.
San Diego Supercomputer Center guy there, just wonderful, wonderful person, talking about their efforts to get some code working with IBM Cell BE,
Okay.
the Cell broadband engine. That's what was in the was it first PlayStation or something?
Oh yeah, that sounds familiar.
I mean,
Yeah.
this
That's
was the heavy iron version of that, but it was
okay.
they got stuff working, but it was like, no, no
Oh
good.
wow.
There was
Oh,
showstoppers. It was just not going to work. There was
bummer.
FPGA stuff, which has been going on for
Huh.
years and years and years. Um, all kinds of
That's
all
funny.
these different little things going on. And this was international, but the uh, kind of the moderator for the conference was Todd Martinez, who's a brilliant quantum chemist who I've had the pleasure of working with, and um, but he had done a Terracam. He had started doing some quantum chemistry code directly on GPU, and
Oh,
this stuff worked. Okay,
nice.
it and this was basically the consensus at this thing. It was like, okay, we can stop messing around. The thing that is going to work is NVIDIA GPUs, and we can use CUDA. And the kind of the takeaway there was like, you're not going to port code. You're going to be writing code from scratch.
Oh,
You're going to be rewriting stuff for GPU. Now
wow.
that has changed because of the massive support that NVIDIA has pumped into this.
Right.
But that meeting was pivotal. That was kind of the point where, like, do it. This is it. We stop messing around. This is what we're going to do. And NVIDIA jumped on it and they just killed it. I
Nice.
mean, they just did everything right. But that was great. I loved working with Todd. Um, Brilliant guy. He's at Stanford now. Just a wonderful scientist and
Nice.
great person. Um, Todd, I don't think you'll hear this, but
Maybe.
hey. Um, but anyway, so yeah. So when I say NVIDIA like kind of drove this stuff forward, I mean, I'm serious about it. Um, but yeah, back to the GTC.
Mhm.
Now, these have been online for a couple of years now, and they're just
Right.
have grown. I mean, massive. Hundreds of thousands of people attending, um, and they've gotten pretty good at it.
Right. Yeah.
The first one they did like this was a little bit rough, like, but then the next one's like, whoa, hey, they've always done that. They've always improved their meetings. It's just
Yeah, they're
talk
good at
about
it.
jumping.
Yeah.
They're very good at it. Um, but I'll tell you what, last year, this is the contrast for me, and this is why I really wanted to talk about it.
Mhm.
Uh, at the meeting last year, I try to, I'm trying to attend stuff live and do all this and be involved
Hard.
and talk
That's
to
hard.
people. And it's very, very difficult. I'm really looking forward to hopefully being back in person again. Um, but so I try to attend talks that are like panel discussions
Mhm.
from, like, HPC leaders and, just whatever different kind of domains, and just see what people are working on, what the problems are, what the general feeling is.
Right.
And machine learning and HPC has moved heavily into the GPU,
Right.
and machine learning has moved heavily into HPC, into those traditional high performance computing things, scientific computing.
Hmm.
Um, so, but last year I left the meeting. I felt discouraged.
What's that?
I was like, oh man, and like that almost never happens to me
Yeah.
at GTC. I usually feel like, wow, this is great and great, great, great.
Right. All kinds of
But
cool
no,
new
I
stuff
left
coming.
feeling I was discouraged. I felt overwhelmed by complexity.
Hmm.
It was it was just like overwhelmingly massive complexity for everything that anybody was doing. It's just like,
Weird.
oh, this is not. And there was problems, and people were going, we don't know how we're going to do this. This is, and it was also kind of one of the end things is like, okay, autonomous vehicles is going to be
Hmm.
like way, way, way harder than anybody had imagined. And it was like exposure was like, okay, well, we don't know how to do this. We don't know what's going on here.
Yeah.
And the HPC side and the scientific side is like, okay, we're trying to do this. We don't know how we're going to do this workflow. We don't. It felt that was how I felt when I left it. I
Yeah.
felt overwhelmed by complexity and
Yeah.
discouraged by hurdles and
Hmm.
difficulties. This year,
Yeah.
flip that on its head.
Awesome.
Um, that I think that last year was kind of the acknowledgement and of serious problems, but
Okay.
and it was like we're not even sure what our way forward is. But this year it was like, okay, we found the way forward, and it was like this is working, things are becoming settled. People are talking, and workflows and whatever are being
Yeah.
established, and things are being worked out.
Nice.
And so it was way different, and I left it going, okay, this is great. And for whatever reason, I don't know why I felt overwhelmed by the complexity
Hmm.
last year, but I did. This year I felt a lot more comfortable, and there was also like Bill Daly, the like the chief, like, great inventor guy at NVIDIA.
Yeah.
His group does this. I mean, they're like the Skunk Works, X Works, whatever. And brilliant guy. But his talk, his keynote, he was really addressing some of these issues that were kind of like brought up last year about like autonomous vehicles and stuff. And it was like,
Right.
okay, and he doesn't he he gives you the real scoop and kind of what they're doing, and it was like, oh, okay, they've totally acknowledged how difficult it is, but the way forward was there.
Cool. Cool. So you think
So
last year was maybe just like a recognition of like the early days, right? Like we're only just now making real steps down this path, and it's kind of big and scary and unknown. And then now
well
that they've
it,
had some time at it.
it was kind of like that, for several years now. There's been this big excitement and enthusiasm about machine learning and all these things you can do with it and
Hmm.
all this kind of stuff. And
Yeah.
and a few years ago, the HPC world, the scientific computing world, like went, okay, we're all in on GPU computing, and we're all in on integrating machine learning into
Yeah.
the scientific computing in general. But so there was enthusiasm, and then it was like, problems,
Yeah.
and then but now it's like, yeah, the main takeaway I think for it was that I felt like there was light, there was like a way forward, and um, and things were being settled. I'm being very vague here. I'm being very vague because it's just my big picture takeaway of how I felt about
Sure.
like the panel discussions and stuff like that.
Yeah.
So it was very good. It was very good. So that was quite nice. You know,
Right on.
um, Yeah, and the talks and stuff were just fantastic. Um, and if and I highly encourage anybody that didn't do GTC or doesn't know really about it, to check out, oh, what do they call it? NVIDIA On Demand.
Oh, right on.
NVIDIA On Demand. Um, I have that on a browser over here, but the they're really good about getting the talks up online for you to go. In fact,
Yeah.
that towards the after a couple of days of that meeting, I was doing time shifting, on a lot of talks, at least where there wasn't like where I felt like I might want to comment or stuff
Hmm.
like that. So I started because they were getting them up like within like an hour after, with less than an hour after they were brought live broadcast.
Nice. Wow. That's that's a good turnaround. It's usually
Yeah,
other
yeah.
conferences that I've gone to, I get the recordings 3 months later.
Yeah, yeah. They were right on top of it. So I was able to go in and, like speed up things a little
Nice.
bit and catch up and get actually more talks and stuff in the time that I
Wow.
had given myself for engaging in the meeting. But yeah, NVIDIA On Demand is highly recommended. The keynotes there, all the big important talks were there. Oh,
Yeah.
it was wonderful.
They got everything. Mhm.
Andrew Ng gave a talk on data-centric AI. I I I I adore Andrew Ng. Hey, and he hasn't been at GTC for, wow, quite a few years.
Oh,
But he's one of the I'll call him one of the godfathers of machine learning.
cool.
He's a
Wow.
super important figure and one of the nicest people on the planet. I mean, this guy is a gem. Okay. And to see him on there and talking, it was just it was great. So that kind of set kind of that tone a little bit.
Yeah.
Um, but yeah, the technical talks were great. There was massive variety. There was like, what, oh man, I don't know,
Yeah.
700, 800 talks or something.
Yeah, I'm just looking at the different categories. It seems there was
Oh
some
man.
really good stuff. I mean, they got it split out by simulation stuff. They have autonomous machines, the data center networking, data science, deep learning, accelerated computing, graphics and design, high performance computing, Internet of Things. Like, yeah, there was a lot going on this year.
It was it's huge. It's yeah. Yeah, I mean, and there was a lot of stuff, in the production, post production kind of video, that kind of work and stuff. There was a lot of that stuff. Omniverse
Hmm. Hmm.
um, was a big domain, a big topic. Um, Lots of good stuff. And on the technical side, kind of, what was going on there. They introduced the Hopper GPU architecture. That's after Admiral Grace Hopper.
Oh yeah,
Okay.
okay, okay,
The person who coined the thing, like there's a bug in the computer because it was
right,
actually a moth in with the
yeah,
vacuum tubes. Uh, and she was
so
also the
much fun.
one that did that phrase. Uh, it's better to ask forgiveness than
Oh yeah, beg
oh
forgiveness and ask permission.
yeah, 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 yeah.
Yeah.
That's her.
Oh,
Okay.
that's cool.
Yeah,
That's one of my favorites. I like it.
she's yeah, great. Anyway, so this one is named after her.
Okay.
And this is NVIDIA's um, accelerator architecture. So this is the follow up to like the A100 for
Oh,
the
okay.
the
Like the Tesla style cards.
yeah, yeah.
Okay. To
And
throw back
and
even
this
further.
yeah, and NVIDIA does this every couple of years. They roll out a new architecture update on for that high end stuff. I don't know if we'll see. Well, I don't know. We'll probably see a Hopper based GeForce.
Hmm.
Um, Probably the same kind of way they did it with the Ampere.
Sure, sure.
Um,
It'll be a year
you've
or
got
two
that.
kind of
You've got
thing.
you've got the A100 in there, and that stuff, and that's like, crazy. And then that was the A100, the GA100. Then there's the GA102, which is
Mhm.
like the stuff that was the GeForce cards based on the higher end, and the GA103, whatever. So those are things that have like way stripped down all of the a lot of the really high performance stuff,
Okay.
and special features are stripped out of it, and that's what winds up in the GeForce consumer cards and the Pro cards too.
Hmm.
What used to be Quadro.
Right.
Um, yeah.
Yeah, that's a whole thing.
But anyway, man, they've been doing this every architecture. It's like at least doubled
Wow.
performance, and they've been doing
That's
this
right.
for ages, man,
Yeah.
ages. It's on the CPU side, we get single digit percentages, right?
Yeah. Yeah, if we're lucky.
On the GPU side, it's like 200%.
Yeah.
It's
I think I remember you doing
crazy.
a test. I think it was like a bunch of the Titans generation
Oh, I
over
did. Yeah,
generation,
yeah,
and then
yeah,
with a comparison with the A100, and yeah, you showed like it's every generation it's been
yeah.
double, double,
They
double,
just
double,
doubled,
double,
and
and
they just
that's
keep doing that. It's just
that's
crazy, and they're
yeah.
at some point, I thought they were kind of
Oh,
already kind of hitting a little bit of a wall there, but no, man, they knocked it out of the park.
that's
The
cool.
Hopper will be great. They've got a really cool architecture with it. Um, they've got a CPU called Grace, right?
Oh, nice,
To
cool.
go along
Grace
with Grace
Hopper, they go
Hopper, right?
together. Nice.
And so they've got this cool module that you can configure in different ways, but you've got the great, this is an ARM, this is a high end, a high performance ARM. This is not like your phone ARM.
Sure.
This, an ARM CPU, and then a Hopper GPU um, on the basic same board. So this
Right.
stuff is like
Oh,
right there. It's
yeah.
like, yeah, this is not separate stuff. We're talking about, you know, um, re, re, you know, reducing the size of the interconnects,
Right.
the distance of the interconnects for things to communicate and stuff like that. Amazing, amazing.
Oh man.
But yeah, Hopper at worst, I'd say it was like it's a doubling, and at best
At
for a lot of
worst.
stuff, it was like maybe 5-6x performance improvement.
Wow.
And on top of that, on their library side, the software side,
Right.
CUDA and all the support libraries and stuff under there. Again, it's another like I couldn't believe they made so much improvements in their compute libraries, because
Nice.
I mean
Nice.
we're talking about like stuff that's 50%, 100%, like a doubling performance just in the performance of the freaking libraries.
Just the,
It's
like
like,
code optimizations and stuff. Is that
yeah, yeah.
wow?
It's like, man, how did they manage to get more performance like that? Um, but you take those two things together, the hardware and the software as multiple factors of performance increase, they
Right.
they
It's
multiply
insane.
together, right?
Wow.
So, yeah, it very, very cool. I was very impressed with the hardware.
Yeah.
Um, yeah.
I want to grab this question. I will interject
Oh,
and grab
sure.
this question from Ron Kaplan, who he said hi,
Hey,
Don, early
hey,
on
Ron.
when we first started. He asks, can you talk about the high TDP of the it says H100, but I think he means A100, and whether or not you think one could limit the power with little loss of performance like the 3090 tests?
Yes.
I
uh,
imagine the same principle would apply regardless of the card. As long as you're able to as long as the
oh,
little tweaks you were doing work, I don't see why
yeah,
not.
yeah, yeah. Okay, I only tested that
Oh, he did mean
on.
H100. He says Hopper. So yeah.
Oh, yeah, yeah, yeah. I think because that's spec'd at very high power requirements. I'm
Okay.
I'm I'm not sure. I mean, it may be one of the crazy ones,
Hmm.
like
500 watts or something.
500, 600 watts, something like whoa, whoa, whoa,
That's
whoa, whoa.
outrageous.
And maybe that's their secret sauce this round, for getting the performance. Um, but yeah, yeah, Ron, and that's really great. I did that testing um, a while back, and I wrote that post on how to set up System D to automatically power limit your GPUs and stuff. So that something that's just automatically on boot. Um, and the testing that I've done on that, it was always like I could drop like 30% of the power and only lose a few single digit percentages in the performance.
Right.
And so and that's really true in the consumer cards, because you can easily drop a 350 watt 3090 down to like 280 watts or something. I don't remember
Yeah.
what I dropped it down to, and you're still less than 10% of the performance loss. That's compute performance loss. Okay. Now gamers will have a different notion of what this means, but for computing on the GPU, it was like, hey,
Yeah, why
yeah,
not?
you could definitely do the power limiting, and that's a way to deal with multi GPUs in a workstation.
Hmm.
You can, because you generally you want to keep your workstation under a kilowatt of power draw. You can push it a little bit more than that, but really you kind of want to keep it down there. Um, and if you look at some of the NVIDIA's data center GPUs other than the A100, I think there's something like an A10, which probably is performance equivalent of 3090 or I'm not even sure, but it's like 165 watts.
Wow, that's
Yeah, it's like what? Yeah.
nothing.
So
Yeah.
so so um it's possible to bring those down. It'll be very oh yeah, I'll be testing on the new one, the 3090 Ti.
Hmm. Hmm.
Right, that thing's
Now
crazy, right?
that thing has got to be ripe for power limiting. 450 watts out of the
Yeah,
box
450
TDP,
watts.
like
Oh
that's
my god.
insane. Like
Yeah.
that's come on. Really,
Now
I'm
now
gonna need a second power supply just for my graphics card. This is getting ridiculous.
yeah, I mean, it really is at that point. That's kind of the thing. It's like, yeah, you'd probably want to put a stuff. I mean, um, but yeah, that one will be interesting to check. And Ron, I'll be doing that. I'm getting back into labs. In fact, if I don't get on with some of the other stuff I'm going to talk about, you won't know what I'm got
Oh
cooking
yeah,
here.
yeah. Just
Um,
a real quick though, I see this article on Anantech. They say that H100 has a TDP of 700 watts.
Holy mackerel!
Yeah,
I almost swore.
yeah, that's outrageous.
Um,
That's over. That's
wow.
I mean
Oh,
near double the A100. Like and
wow.
seven just shy of 17,000 FP32 CUDA cores.
Oh, the thing is a monster. Okay, so I guess I'm not surprised. Yeah, massive number of transistors on that die. It's crazy. So and you got to power it. Um, but yeah, wow. Okay, well, there's plenty
Yeah,
of work to do on that kind of stuff.
that's
Um,
crazy.
yeah, especially trying to get any of that. So whatever shakes out of that tree, right, that we wind up
Right.
putting in workstations.
Yeah. Wow.
Um, Yeah, double check. Yeah, I don't know. That'll be really, really interesting to find out. But if it's something like that on a chip like that, that's probably not going to be there's there's probably not going to be that much room for lowering that down.
I imagine
But
not.
yeah, I mean on the G4 stuff and stuff that's got display output and stuff like that. Yeah, you've got some headroom to play with in there. Um, wow, yeah, that's wild. Yeah, okay,
That's
wow.
yeah, server level stuff for sure. Like there's we're not
Yeah, and then that totally is. That's what I was saying. I'm not even sure if that's going to trickle down into um, the professional and the consumer, and to GeForce.
yeah.
Um, but I'm sure they've got some stuff cooking. They'll, probably by the end of the year they'll have something, a new GeForce 4000 series or something.
Yep.
I
That,
don't have
that's
any
the
inside info on
no,
that.
and
None of us
despite
do.
of all the things that we do end up having like fancy secret knowledge of, NVIDIA is probably like the one we never ever do. They
Yeah.
never,
Yeah.
and that's not just us trying to cover our butt. Like that is the legit. NVIDIA doesn't tell anybody anything.
Yeah.
How many times has
Yeah.
Jensen been on live stream and just been like, "Oh, look, graphics
Oh, yeah.
card."
Oh, yeah. Oh, yeah. He's
That's their
thrown
thing.
off his own marketing team
Everybody's
before.
scrambling like, "Oh,
It's famous for that. It's wonderful.
yeah." So they don't tell anybody anything.
Um,
So what else have you been up to? So GTC was awesome.
yes. Yeah. I'm really glad I got to talk about that. The main thing that I've been kind of like working on, is benchmarking stuff again, because I really haven't had. It's time for me to have a new round of like, okay, here's a bunch of code, and this is how it performs on wide range of hardware. Um, all the GPUs, all the CPUs, and do all that stuff. It's been very difficult for me to do that, because we have assets, we have resources in
Mhm.
Puget Labs, but they are all running Windows.
Oh, right.
Okay, and essentially all of my stuff is Linux.
Mm-hmm.
Okay, um, so now I've spent at the end of last year, I spent a huge amount of time of working on benchmarking, uh, control infrastructure kind of thing.
Mm-hmm.
And I was trying to do stuff cross-platform, so I can do Linux, Windows, and the Mac too. And
Cool.
and I made some really cool progress there. Like, but going from something that I wanted to do in Linux, then to trying to make it work in Windows, multiplied my effort needed by a factor of at least 4.
Jeez.
Yeah, something that would take me an afternoon to do in um, Linux would take me an entire week or maybe 2 weeks to figure out how to get it to work on Windows.
Wow. Wow. Even
Yeah,
with all the
because
cool new.
Windows is the machine learning and scientific computing. It's not. It's That's in the Linux domain.
Yeah.
I mean,
Even with like the
and a lot of
WSL stuff, all that.
what's that?
Even with the WSL stuff and all that, that wasn't helping at all.
WSL is awesome.
Okay.
And now the official Windows 11 WSL in there actually has GPU compute support.
Right.
Okay. And so the Linux stuff that I'm doing, which I'm more focusing on right on now, getting
Mm-hmm.
actual real benchmarks rather than this infrastructure kind of stuff, um, that will run fine
Oh,
in
cool.
on WSL. So that's really cool. And I'll be doing Windows stuff too, native Windows, where it's appropriate and where I can do it without extraordinary pain.
Yeah. Oh, that's good.
Yeah, I shouldn't beat up Windows too much, because there's a lot of great stuff and a lot of stuff really does work. It's just not as well supported.
And I feel like
It's an
there's a
afterthought
difference.
usually.
There's a bit, I feel like you were saying that a lot of the real work is done in Linux and stuff, and it's like Windows is probably more for like hobbyists or kind of just getting started sort of deal. Yeah.
Yeah, I mean, you can do serious work in Windows, and there's no
Yeah.
denying it. And there's nothing wrong with it really. But NVIDIA, a lot of the machine learning frameworks, and a lot of stuff is like they don't really care about it because none of them use it.
Okay.
And there's the big focus on the cloud and having stuff running in that kind of infrastructure, and that's all going to be on Linux. So that's just where the development focus is.
Yeah.
You can make the stuff work on Windows, and a lot of stuff does. A lot of stuff. I'm not. You can do legitimate, serious, really cool work in Windows.
Oh, okay.
Uh, but just in general, it's fraught with peril. You can run into really serious problems that can slam you down for some time. And I mean, I almost gave up entirely on trying
Oh.
to port some stuff to Windows because it was like, it's impossible. And then I figured out ways to do it. And that's kind of, let's see, yeah, so I'm talking about benchmarking stuff.
Mhm.
Yeah, three things I want to talk about. First of all, my benchmarking boot server. Very, very cool. This solved that problem of all those wonderful, juicy machines in labs running Windows. This solved a huge problem for me there. But that, and then I want to talk about MicroMamba, which gave me
Yeah.
the cross-platform stuff for anything that involves Python, which is a lot of stuff.
Right.
Okay.
Yeah. That's
That was
like
my
the
solution that
major.
actually allowed me to take care of stuff in Windows natively and stuff like that without, because I'm trying to do things that are portable that don't require like a user of benchmark to have to alter their infrastructure on their system.
Right. Okay.
So that they
Yeah.
don't have to install extra stuff and have, junk spread all over their system that they can't clean up. So that's where MicroMamba comes in. Very, very cool. Super cool. And I'll explain what that is. The other thing, which I love is Enroot, and especially the container bundles. I'm doing a whole bunch of stuff right now where I'm wrapping everything up in self-running container bundles. They're portable, and you can run those. You can just take these things basically as an executable for whatever it is that you're doing, and you can put it on any. This is Linux, but
Right.
you can put this on any Linux machine. You don't have to have anything installed. You don't have to have any runtime for Docker containers or anything like that installed. This just runs. It's all in there. It's
I
all
love
in the
it.
bundle. It's very, very cool. Super, super cool, and it's perfect for benchmarking because some of the, I'm doing molecular dynamic stuff right now, and man, some of the setup for some of that stuff is fairly involved.
Sure.
It's like, oh, okay, how can I deliver this to somebody that doesn't have any of this stuff on their machine? Okay, the obvious
Yeah.
thing is to use a container, but then it's like, okay, I don't want to have something that's using a container that requires them to have like a Docker install or something like that.
Right.
Right. So yeah, Enroot bundles are just fantastic. But let's yeah, I'll talk about the my boot server.
Yeah.
Okay, I already talked about the problem that I have in Houston. I'm going to do a screen share.
Sure. The one you've added already, I can pop that up.
Yeah. Let's pop that up.
I also
Okay,
posted the
yeah,
link
there
to
it is.
this article in the chat.
Let me bump that up in size a little bit. You don't have to read this, but this is a fairly recent post that I did on how I set this up. LTSP, that's the Linux Terminal Server project. That's been around for a long time, and I've aware of it from way back. And the original thing is, it's kind of like depicted a little bit in this.
The little graphic there.
Yeah, in the little graphic there, you've got the big penguin and you've got the little penguins. That was the logo really from the original LTSP, and the idea there was to create a Linux terminal server. So
Sure.
and the server was like, that the more heavyweight machine, and it was serving images, boot images, and all that kind of stuff. It was serving the OS to essentially, smart terminals, like minimal machines.
Yeah. Almost like how you would do old school mainframe terminal kind of a thing. You got one big giant machine in a basement somewhere and a bunch of little dumb
Yeah,
terminals just connect to it. This is similar, I
yeah,
suppose, a little more
yeah, and
advanced.
and a lot of Windows Server stuff is kind of done in that same kind of vein, right? And this was just kind of that was the origin of it. And when I was looking at this, it's like, okay, I'm going to set up a TFTP boot server with DHCP, and and all this stuff, which I've done in the past, because what I wanted a box, just a simple box that I could use as a network boot server and file server, and and take care of networking stuff like that over the network, so I can just plug a network cable into any machine that I've got in labs, and just boot it to Pixie boot,
Oh, that's
uh,
it. Yep.
to network boot to my thing, and have my OS and all of my stuff on it. So I was going, oh, and I'm looking around, I'm just going, okay, well, I've done this in the past. It's like, there should be an easier way to do this than like rolling all of this stuff yourself. And it's like, no, man, it looked like it was the same way I did it 10 years ago, like,
Hey,
oh, for
right
crying
on.
out loud, man. But then I looked at LTSP, and like a couple years ago, they completely rewrote it.
Oh,
They
okay.
they completely redid it from scratch. So they maintain two versions, but the current one, if you take those penguins in that logo there,
Hmm.
reverse that.
Right.
Now the terminal server is the minimal machine,
Hmm.
and um, and the compute, everything that's going on is going on the clients. Okay, so this
Yeah.
is exactly what I wanted, and this is really nice. It simplified so much of the setup for this. It was just like, oh man, this is great, and that's what this post is about.
Yeah. That's how
Um,
you set this
yeah,
all up.
yeah, and this is my benchmarking platform for diskless workstations. So
Mm.
basically, I'm serving the a network boot. I'm serving the OS, the Linux OS, over the network to the machines. And I've got a mounting root with um, like a secure shell FS,
Mhm.
and home is mounted with a NFS network file system, and I've got another drive in there that's mounted. All this stuff gets mounted on the client, and I never touch the hard drives on those machines.
So there's a weak machine that just feeds the Linux install to the big benchmarking machines, and that's just all held in memory then, because it's like it's not actually being written to any of the hard drives of the benchmarking machines.
Right. It's in memory and in network mounts.
Wow. Oh yeah, okay, because yeah, some of it has to be from the I'm
Yeah.
unsure of the right vocabulary, but what would be the main frame, I guess, in my
Yeah.
limited
Yeah.
knowledge.
It's um yeah. Yeah. So
Okay.
everything basically comes from um the boot server, but
Yeah.
all the performance is on the client.
Wow.
So it's very, very cool. It's very, very cool. And what my use case here is not really what their intended use case was. Their design there is for like managing learning labs and stuff like that, computer
Right.
labs, and it's perfect for that. But it turned out to be, yeah, hey, this was just great for my use too, and that's what I've documented in this post. Um, but that lets me. So I'm just using an Intel NUC.
Oh, that's the
It,
server, the main boot
yeah,
server?
yeah, it's
That's
just one of
awesome.
those
The
little guys,
little ones?
not the little one,
Oh,
the
okay.
bigger kind of
The,
cool one.
um, oh, dang,
I'm not
I can't
using.
recall the code name, the something something canyon, not the Dragon Canyon that just came out, the one prior. Skull Canyon? Devil's
Something, yeah.
Canyon? I don't know. They
And
got too
the
many
one I'm
canyons.
using is the not the current one. It's the previous
Yeah.
one. Current
Yeah.
one is very cool. Man,
That's
you
a
can put a
beast. That's
serious
something else,
GPU in
man.
there, and it's
Yeah.
got like 10 gig Ethernet and all this kind of stuff.
Yeah.
But I'm
That
using
thing's
10
no
gig
joke.
Ethernet on this on my boot server now. Um, but I'm using it with a card.
Right.
But anyway, so yeah, it's just that little thing there, and network cable over to the thing, reboot the machine, select my Pixie server, boom, boom, there it is.
I love it.
And then, and it's isolated. It's a completely isolated network.
Mm.
Um, and the it um, you know, the networking goes through through the terminal server. So
Okay.
it's isolated, but you have full network access. And then I log in remotely. I come in to the server, and
Mhm.
then I log in to whatever clients I've got hooked up from there. And so I can
That's
do
rad.
anything I want, and all of my code is there. Everything that I need is there. It's all there.
What a
And
trip.
so that really solved the problem, because in the past I used to have to go down there, for like arrange a time where I can use a machine for a day or two,
Right, right.
right? And then go down there and actually take it like an NVMe drive out and put a new one in, do an install, do a setup, do all this stuff. So I didn't do a whole lot of testing
Right.
because there was a lot of
All the
friction.
setup. All the setup. Yeah. Just
Yeah, it was really annoying, super annoying. But this is actually really cool too. I
yeah.
love this.
It
I'm going to set something like this up for myself at home, even
yeah,
to use
it
some of the
seems like
machines I have here.
it's almost like a variation on virtual machine, kind of. It's like almost but they're physical, like they're real machines, but it's almost like a virtual operating system, kind of. I mean, kind of.
Yeah,
It's really neat way of serving it up without having to go through it, because it's like one and done, right? You set up the server, the boot server, and that's it. And then now it doesn't matter about the testing hardware. Like we can swap that out all day long, and you just boot into the server and it just works. It's ready to go.
Yeah, I
That's
can
so
have
cool.
multiple images on there for whatever I
Yeah,
want the things
and
to boot into,
I guess
whatever.
it doesn't matter how many benchmarking with clients then either, right? Like you could have a dozen of them all running different stuff all at the same time and whatnot.
Yeah, at this point right now, I'm still just kind of getting everything set up and experimenting with it a little bit. Works pretty cool. Um, there's some annoying stuff with like sort of like Marvel 10G network controllers that are on one of the boards that we're going, well, doesn't want to pixie boot.
Always
But
something.
those things are solvable, and yeah, we can just add a switch in there,
Mhm.
10 gig switch, and then
That's
heck, we
super
can
cool.
the machines that I need to test on, we can just leave them plugged in.
Yeah,
Then I come in remotely, and I can reboot things remotely and select what to boot to, so I can just boot a machine into my stuff, run my stuff, take it down. I could do this anytime the machine's
that's super cool.
not doing something else. So yeah, so really, really cool. So that will um, should see some more hardware benchmarking
Woo!
articles coming up soon,
Awesome.
because that really lowers the friction.
Mm,
Um, so that's cool. And anybody that's interested in that, that post that I did there really kind of, I think, uh, clarifies what the new LTSP is like, and gives you some ideas of some cool stuff that you can do to it. That's like, not, you can do with it. That's not really like what its original intent was. And this turned out to be perfect. So, and this saved
love
me
it.
massive amount of effort to set this stuff up. So it was fantastic.
Right on.
So that one, that's really cool. Um, now related on the benchmark stuff. Um, what I was talking about earlier, I was talking about MicroMamba,
Mhm.
and yeah, let's let's go ahead and do that share again, and
Sure.
I will. Oh, okay. Well, okay. First of all, what the heck is MicroMamba?
A very, very small snake.
A very, very small mamba. Um,
Like
okay.
the candies, right? The Mambas? No, I'm just kidding. Sorry.
In uh, machine learning and stuff like, and the Python is very big. Okay, it's huge.
Yeah.
And in data science and machine learning, a really great Python setup to use is Anaconda Python.
Mhm.
Um, and it uses a package manager for Python called Conda,
Okay.
which is really great. And the reason it's so popular in this domain is because a lot of these packages require like external libraries and stuff like that the normal Python ecosystem doesn't easily provide. Although it's better now. Okay,
Okay.
Python.org and pip and stuff like that can actually pull needed libraries and stuff like that. But that's the real strength of Conda. And so for data science, machine learning, and stuff like that, that's pretty ubiquitous.
Mhm.
And I prefer it. This is my way for setting up Python. And I usually don't use the full Anaconda distribution, but the full Anaconda distribution, which is really easy to set up, includes all of, I mean, just right doing that install includes most of the packages that you're going to want
Okay.
for doing machine learning and scientific stuff, whatever. So it's very good, but it's big, okay,
Mhm.
because it includes a lot of stuff. There is Miniconda, which just does and usually what you do when you set up a Python is you set up environments that are basically like isolated little pieces that have just the dependencies that you want in them.
Okay.
Okay, because that gives you a way to do essentially version controlling uh, of of your package setup. This is another strength of Conda, is that you have great control over the Python version itself if you need to
Wow.
restrict that in an env, and that's a little bit more difficult outside of that world. Uh, but anyway, so you create an env that's got the stuff that you need for your project, and that's what you use when you're doing all your work.
Okay.
Okay. So yeah, so you can do Miniconda to set that up, but that and that installs stuff up, and you create these envs, these environments, and then you activate them, and then you use them. Okay.
Okay.
Now, and Conda's been around for a while. It's not super fast. So there was a project called Mamba that basically is an optimized Conda. It's like massively faster, and it's got a way better dependency resolution code in it. So very cool project. That's Mamba, and the really cool thing in there, and there's Mamba, and there's many, so a lot of people install Anaconda, and they install Conda stuff, and then they install Mamba with that, and they use Mamba instead of Conda itself for
Okay.
package resolutions, for setting up envs and all that stuff like that. Okay. Uh, but now MicroMamba,
Micro.
super cool. MicroMamba, let me see if I can. I'm going to bump this size up here. Okay, you can see this MicroMamba, small pure C++ executable. Okay, this is a standalone little thing. It's like 40 megabytes.
Wow.
And it's got
That's nothing.
it's got all of the important functionality of Conda in it. Okay, and it's
Okay.
contained just in this one little thing. And okay, so yeah, these are all that, activate, deactivate, shell, create,
Mhm.
install, update, remove, stuff that you just your bread and butter stuff that you do when you're creating Python environments with Conda. It's all in there. Now what I did, okay, remember I was telling you I wanted to set up benchmarks, okay, for stuff that involves Python.
Mhm.
I wanted stuff, and MicroMamba there's this executable exists for Linux, Windows, and the Mac.
Okay. Right on.
Okay, so you can use this to set up. You can use it in a way that you would kind of like use it, where it's like an install, and in your home directory you've got this MicroMamba, and it's putting
Mhm.
packages in there and stuff like that. But the really cool thing about it is you can take MicroMamba and you can set its root to a directory in your directory that you're working in, so that everything goes in there.
Oh.
Okay.
Okay.
And so you can, to make a long story short, what I've used MicroMamba to create customized Python environments that I need to run benchmarks. And this stuff is all self-contained.
Nice.
It's all in one directory that I can zip up, and it's like here. And the kind of a crazy thing that I did was I have a simple Python executable, a control program, if you will, that that is real simple, and I can create an exe out of that.
Okay.
So I can use a package called PyInstaller to make an executable of that Python executable. That Python, what it does is it does system calls to call MicroMamba to create the actual Python environment, the Conda
Oh
Python
man.
environment with like TensorFlow and PyTorch, whatever in it that I actually really need to run the benchmarks, to
Right.
run the code. So you run this control thing, and it's got the interface on it, and then it calls that stuff, and then that creates the environment, pulls all this stuff down. So what I have to distribute is just a little teeny executable.
Yeah.
But then it will install TensorFlow on your machine in that directory with that Python from that env that was all set up with MicroMamba. And that may be, like 10 gigabytes if it's like TensorFlow, right?
Sure.
And then,
that's rad.
Yeah, and then that control program uses that then to run the benchmarks and spit the results out. So essentially, I've got a Python executable that calls MicroMamba to create a real Python environment with all of the tools needed in it to run the code. And then it runs all the stuff that I need to run, and it's all in that little directory.
Wow.
It doesn't install anything anywhere else on the system. It's all completely self-contained. And then if you're done with it, you want to get rid of it, remove.
Just delete that folder or whatever,
Just
right?
delete the folder. Gone. It doesn't touch the system.
That's so rad.
So this was a huge deal on Windows because it's like, oh man, if I install any of the, you can't ask somebody to like, okay, yeah, you can run my benchmark, but yeah, you got to install this and install that and install this.
All the
And,
hoops.
by the way, it's going to scatter that stuff all over your system.
Yeah, and then uninstalling all those apps
it.
and stuff is a pain in the butt, and who knows what kind of weird orphan files get left behind. Oh man, that's super cool.
Yeah, and maybe you already have a Python install on your machine, and now this is going to interfere with your stuff.
Yeah, no, your dev projects are all ruined.
Showstopper.
Oh man.
So
that's so cool.
that works really cool, and that's MicroMamba. That is just a fantastic tool. People are using this in continuous, CI/CD chains, like on GitHub, where they're using MicroMamba to create build environments, stuff like that when they're updating their executables and stuff like that. So it's really a nice thing to use for automation like that, because it's little teeny and standalone.
Yeah,
it's one stupid little executable file. Boom.
Right on.
You don't have to install anything. It's great.
So
that is really cool. And
when am I going to have an executable I can run your benchmarks on my computer at home?
I moved away from that because I was spending so much time on it that I wanted to get, just because I was working on all this infrastructure stuff and I wasn't doing the actual benchmarks themselves.
Right.
So I completely stood that on his, like, I'm going to get all these standalone. Yeah. So I run these standalone benchmarks from a control code that runs them. And that MicroMamba was just another layer in there to set up the environment for actually the benchmark to run on.
I see.
But and I have a blog post up on what's it called?
The self-contained
share again real quick.
Yeah,
real quick, share there. That one.
Oh yeah.
Standalone Python Conda envs without installing Conda. So you use MicroMamba here, and so I describe how to do all that stuff in that post. You know, it's got what you need to get going with it. Anyway, so that's really cool. Now, oh man, we're
It's
over.
okay. It's okay.
Oh, I'm
No,
just
don't worry
getting
about
to
it.
Enroot.
We'll get to it. Yeah, no, that's fine. You got a few. It's fine.
Yeah, you know, this will get recorded, so hopefully, maybe somebody will come back to it. But while I'm here, let's see. Let me pop over two things
Yeah,
since I've
that's the
got
one.
the share up. Enroot is a NVIDIA project. These guys are great. I love these guys. I've had really good interaction with it. In fact, Houston, you remember like some of our first streams when you were doing the builder,
Yeah,
and we
yeah.
were talking about Docker.
Right.
One of our episodes became an internal reference for Docker at NVIDIA, and it's because these guys got tired of answering everybody's question. Well, what is this thing? What is this Docker? What are these container things? You know,
Let's go
and
watch
so
these
they got
guys.
tired of. They say, "Here, just watch this. You know, just listen
Oh,
to
that's
this thing that I explain it." That's true.
that's so cool.
um, but so I go way back with these guys, and they started doing this project Enroot, and um, I love it. This is way massively better than Docker. You can use Enroot as a container runtime. So,
Okay.
and this runs as you know, you're not running something as root, you know, that is running root internally and stuff like that. You you can import a container, you know, a Docker container, whatever. You can import that with Enroot,
Mm-hmm.
and then you create basically a container sandbox then with Enroot, and it effectively it basically puts this container um, in your in a place in your directories, in your home directory, and then you can start that container, and when you run it, everything that you do you own.
Hmm.
Okay, so the stuff is not running as root. You own it. This is in your files, in your file system. The whole container is there, and you own the whole thing. Um, and um, yeah, super nice. And I use it. Usually, you know, I'll pull a container package that I want to use, and then I set it up and I run it with Enroot.
Mm-hmm.
Um, and I have it export my home directory into the container. So so when I start the container up, all of my files, everything that I'm doing is right there in the container. So I can use,
Right.
like if I've got a TensorFlow version or something in there, all the stuff that I'm working on, I can just use that stuff.
Yeah.
And then in my terminal right over next to me, I've got the same directory and everything. I can make modifications in there outside of the container. It's the best way to use containers on a workstation, period. It's fantastic.
Awesome.
And another thing that's really cool, you can modify those containers. You can do it in the traditional way.
Mm-hmm.
You can start a container as root, read write, and then like install packages and stuff like that, whatever. And then come back and then and run the container as yourself, and all that stuff's there. But you can also go in and it's just the files, it's sandbox, it's the container is right there on your system. You just go in, you can edit stuff directly in there from your system without even starting the container. Super,
Dang.
super,
Wow.
super cool. But one of the coolest things, you know, and it's small. Okay.
Right. Right. Yeah. Yeah. You were saying it's very tiny.
But what's really cool, and this is perfect for benchmarking, is I can take one of those containers that I've got set up. I've modified it. I've done whatever I want with it. I've got all my stuff in there. I can set it up so that it runs programs automatically when you start it and stuff like that. Then you can do this thing that they've done with Enroot that they call Enroot bundles.
Uh-huh.
So you can bundle this container, and what it does is it creates an executable. And what this really is like a shell archive. If you know Linux and bash shells and stuff like that, this is kind of a cool thing. But a shell archive is kind of like a container that runs. I'm using the word container here in a couple of different ways. But it's got all binary information and everything like that. If you run like the NVIDIA driver installer, the .run version of that,
Mhm.
that's a shell archive.
Okay.
It's got all the binary stuff in it, but it's also got scripts in it that actually do all the setup and stuff like that. And it uses the binaries that you've got also wrapped up. So everything is wrapped up into that archive.
Okay.
So an Enroot bundle is basically like that.
Yeah.
And what it's got in it is it's got Enroot in it. Okay, so
Okay.
Enroot
Okay.
itself is in this container bundle.
Right.
That means you now have basically what's an executable that you can run. You can take this and put this on another machine and run it. You don't have to have Enroot installed. You don't have to have anything installed on that other machine.
Nice.
Okay, because so you've got this container that's just a runnable executable,
Yeah.
which is
That's
really cool,
awesome.
man. It's standalone. You can put that anywhere.
Man,
Nothing else has to be set up or installed. Nothing. It's all right there.
that's awesome.
It's freaking awesome.
Yeah, that's
And
really neat. Man.
so that's what I'm doing right now. I'm setting up most of these molecular dynamics benchmarks because I've had to compile code and create executables and add libraries and add MPI message pass, all this kind of complicated stuff that goes into a setup that you normally need to run one of these things. So I've got them into a container, and then I create a container bundle. So now I've got all of that stuff in a single file that runs as an executable. It's all in there.
Nice.
Love it. I
I want
love
to.
it.
I want.
I'm
I want to touch on this.
I'm
This actually sounds kind of might have a good. This is a good question, I think. Sonic 521 on Twitch. They ask. I have a question. Are there any potential security risks with this aside from the general risks?
There's fewer security risks
I would have thought so.
because you're not
Given
using
given
root.
its self-contained nature, it doesn't have to play around anywhere else but inside its own little sandbox, like literally sandbox.
Yeah, it's literally a container sandbox, and you own it. This is no different than any other executable you would have in your home directory. Okay, now, um, okay, now I'm saying that now this stuff. A real good use for this is on clusters where you're doing you're using Enroot containers in like a resource management system like Slurm or something like that. So you're farming out executables onto a big cluster or something like that. And they have a more tightly locked down um, setup for it. Okay, but um, it's not such a big deal. See, this is one of the main things about it is that with Docker, you have a daemon, a system daemon service, Docker service that has to be installed on your machine and it's running there. That is owned by root. However you set stuff up, right? But then, and you fire up a container inside the container, it's root in that container. It's
Mhm.
root of that container, right? So no, it's ugly and it makes it really hard to work with as an end user because you have to deal with this stuff. It's like, some of the early Docker posts that I did were ways to use namespaces to kind of like
Mhm.
take some control of the containers to make them easier to use on a workstation.
Yep.
But when you're doing Enroot, your Enroot is installed and you own Enroot. You install that in your home directory. It's your program.
Yeah.
Well, okay. No, let me back up. Let me
There's
back up
some
there because
caveats.
I just lied to you. You install Enroot is it's an application when you install it on your system. Okay?
Right.
And it uses, all the cool, facilities, namespaces and whatever, everything that's flying out of my head right at the moment, to manage these container bundles for you. But when you pull a container, you own that container that you pulled.
Mhm.
Okay, so that's a squash file, squashfs file. This is the container, and then you own it. And then with Enroot, you create the sandbox in your home directory that you own. If you go in there and look at all those files in there, you are the owner of everything in there. Okay. When you fire up that container, you own that container.
Right.
This is you. So this is, um, you can change yourself. You can start that container as root.
Mhm.
Okay, if you need to do something like do an apt-get install of something into that container, okay, because that means you have to be root in that container to do that. But you would
Sure.
have, that's the same thing you have to do on your system.
Right.
Okay, so um, so in my opinion, it's way more secure because it's no less secure than anything else that you installed and ran in your own user account.
Makes
That's one of
sense.
the
Yeah.
things that is really nice on a cluster because the individual user owns this thing that they're running. Okay, so um, yeah, really good stuff. I wish NVIDIA would actually kind of promote it more because they don't, even on their own container repository, NGC.
Hmm.
But but doing these the container bundles, then yeah, that's an executable. When you give that executable to somebody else, they run it on their machine. They own that executable. They're running it as them. So it's right there. Now, if you're exposing ports like for network applications and stuff like that, it's the same as if you had done it yourself because you own all of that. So it's the same as if you had installed everything yourself in your own home directory. So in my feeling of it is that it's way more secure. You can embed, checksums and stuff like that into the container bundles, so you can verify that nobody's messed with your bundles and stuff like that. So there's all the security stuff that you would expect in there. I love it, but man, this makes doing these really complicated setups for benchmarking just great because then I can just drop those onto my boot server as as a bundle and run the benchmark. It's all wrapped up. I don't have to mess with anything, and I can have all these crazy installs. Each one is completely separate. I might do
That's
more with
super rad.
this publicly too. Actually,
Yeah,
like
man, you
making some
should.
of this stuff available for people to
Mhm.
download and use
Yeah, yeah.
because it really could be a really cool way for people to fire up some version of TensorFlow or something like that they just want to experiment with. They
Right?
don't want to do a setup.
That'll be super cool. Awesome.
Way over.
Yeah. I think we should wrap it up though. But oh man, this was really good to get caught up on what you've been working on, Don. This was really cool.
My apologies to everybody for any questions that I didn't get to because,
I think we got
meh,
everything.
meh, 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 meh.
That's all right. Wait,
um,
where did my mouse go? Oh,
yeah,
there we go.
I love you all, and
Yeah. Ah,
I'll try to be more public and get more stuff out to you. So
yeah, right on. Yes, I'm with the Sonic 521 on the Twitch. He said this is all brand new to me, but it sounds great. Same. I'm in a very similar position, but it is very cool stuff. This is all very neat. They ask one final question: will it ever become open source? I
Enroot,
think.
Enroot's open
Um,
source.
I was gonna say I think, and even really the work that you've been doing, it's all in the
Yeah,
it's all in
yeah.
the blog
Oh yeah,
posts
yeah,
and
yeah,
stuff.
yeah,
You can
yeah,
totally just follow along with what Don is doing.
yeah. I've got GitHub repos. Okay, a lot of the stuff that I'm doing right now is in private repos. Um, but yeah, I plan on making the stuff available, and so you can see exactly what I did and how everything is set up. Um, Yeah, that's DB Kinghorn on GitHub. So you can see there. Please don't hold any crufty, junky looking repos against me on there, because I have a lot of stuff that's like was started and not gone anywhere with it, and whatever, So there's a lot of cruft in there. It's not a really well managed GitHub account. Sorry about that. But yeah, I plan on having stuff open. And especially the benchmarks. That was the whole idea. Is that I want these things to be publicly available for people to run the benchmarks, but I'm not going to hold back on how I did it.
Yeah.
Okay,
That's so
I'll
cool.
write that stuff up, and it will be available for you to dissect and do your own thing with. Yeah, absolutely. I'm totally on board with that. I'm a scientist, man.
Yeah,
Share the knowledge.
that's right. Hack the planet. No. All right. Well, okay. So then, we'll wrap it up. We'll say goodbye and thank you, Don, for taking the time out of the day. And I always like to thank the audience as well.
Houston, yeah, we should probably do this more often because
Yeah.
it's really fun.
Yeah.
It's really
Yeah.
fun.
Even just talking about what it is you're working on. Just, hey, man, what's going on?
I'm always doing something crazy,
Yeah.
It's an endless supply of that
This
stuff.
isn't what they meant to do with this, but I'm a scientist. I do what I want.
Yeah, yeah, that's what you do.
Yeah. Well, right on. And again, like I said, I'd like to thank the audience for joining us as well. We do this every Wednesday, most Wednesdays, nearly every single Wednesday, 1 p.m. Pacific. We have a potpourri of content on our live streams. Sometimes it's going to be pre-recorded stuff from, external experts and things. But then I think we'll have our internal experts more for the live stuff. And yeah, just mark your calendars. We do this Wednesdays, 1 p.m. Pacific. And yeah, I think that's it. That's all. And we'll see y'all next time.